Hello there, welcome to the October 2020 paper. Here we're looking at the final question of the paper, question 14. The curve has equation y equals g of x. Now we're given some information about g of x. G of x is a cubic equation with the coefficient of x cubed is equal to the coefficient of x. The curve has equation y equals g of x passes through the origin, and the curve with equation y equals g of x has a stationary point at 2, 9. Find g of x. Okay, so far what I've got is that g of x is equal to ax cubed plus bx squared. Now the coefficient of x cubed is equal to the coefficient of x, so it's plus ax and plus 0 because it goes through the origin, so there's no plus c on the end. Now the curve with equation has a stationary point at 2, 9. Now we know two things about that point 2, 9. We know A, that it's a minimum point or a maximum point, but it also goes through that point 2, 9. So let's put that in first. That it will go through the point 2, 9. So 9 equals 8a plus 4b plus 2a, or in other words 9 equals 10a plus 4b. Okay, so that's information number 1 about a and b. Let's now differentiate. So it's going to be g dash of x equals 3ax cubed plus 2bx plus a. And we know that there's a stationary point at 2, 9, so we know that when x equals 2, the gradient equals 0. So it's going to be 0 equals... Now 2 squared is 4 times 3 is 12a plus another a on the back, so that'll probably be 13a now. And then it's going to be 2 times 2, which is 4, so it'll be 4b. So we've now got simultaneous equation number 1. And what I'm going to do with them is I'm going to plug them into the simultaneous equation solver on my calculator, because I am feeling very lazy and I've done a lot of the good work here. I've done a lot of the context into the equations. So it's 10, 4 equals 9, and 13, 4 equals 0. And I get out that a equals minus 3 and b equals 39 over 4. So there we are, find g of x. G of x is equal to minus 3x cubed plus 39 over 4x squared and minus 3x. So there we are, that's the answer for part A. Now we move on to part B. Prove that the stationary point at 2, 9 is a maximum. So what we'll do then is we'll do the second derivative, so d2y dx squared is going to equal, let's just do it in terms of a and b and then we'll put things in later. It's going to be 6ax plus 2b. And we need to prove this is negative or positive. Let's put x equals 2 in and the values of a and b. So if a is minus 3, it's going to be 6 times minus 3 times 2. Let's do that on the calculator so we don't make a mistake. 6 times minus 3, 6 times minus 3 times 2 is minus 36. And then plus 39 over 4 times 2, so that'd be 39 over 2 is, let's do that on the calculator as well, so plus fraction button, 39 over 2 equals minus 33 over 2, which is a negative number, and when you get a second derivative being a negative value, you get a maximum point. So therefore, maximum point. And there we are, that's the answer for question 14, and that's the final question on this paper. So there we are, so 9 marks for that question there. Let's now maybe move on to the applied paper. Hopefully you found these videos helpful, and thanks very much for watching.